So welcome to a very small piece. It's supposedly holding for 15 minutes. It is something that I just put into it out of interest. It's not really a key tool that you have to use. In fact, it's more like not really marketing, but it produces a high-level result. It gives you a performance snapshot of your application, and we will look at how that actually looks like. It generates kind of HTML output, something that you can just snapshot as a picture and somewhere include into a slide. The idea here is you can just explore three aspects of your program, which is the intranode performance, and it is the MPI communication performance, and it is something else. It is the storage performance that you can look at if you want. And it leverages, if you have these Intel tools, it leverages the existing infrastructure like the drivers, the kernel drivers that are used to extract performance results from the performance monitoring unit, which is part of the CPU. But the interesting part is also that you can download this separately, free of charge, and it is like a shell script that you just launch and prepend to the execution of your application. And then you can explore these three aspects and just get kind of three different charts with, say, high-level detail, and not really deep details or analysis, but some, really, the name says it, kind of an application snapshot. Okay, let's look at this. Objectives here are just to learn about these performance snapshots and then to get hands-on and eventually try it for reporting the success or the progress of your project to some extent. If you report to someone what you did and what the progress and result was, you might have some fun with this. Essentially, as I said, you run a test case, and the intranode performance is just using either sampling to sample performance numbers from the CPU, or it eventually uses the performance monitoring unit. I don't know. I have to ask the developers what kind of mechanism they use. What I heard is for the intranode performance, it seemed to be sampling. The last people at Bologna, they tried this and they found it used sampling for gathering the performance results, which obviously has some impact on runtime of the application itself. But there is also a communication and MPI performance snapshot, which had zero impact basically, and it probably reuses some of the interception technology or call interception that my colleague in the previous talk introduced. And it essentially instruments your MPI calls and then gathers some results and presents them in some way that you can easily consume. And then there is this third part, the new addition. Normally with these analysis tools so far, you never had an aspect or a possibility to look at storage performance. If your application is not only has some compute in it, but also some I/O, which is still, it could be a large chunk of the time to solution. You can also essentially profile the storage aspect of your application. As I said, there's this application performance snapshot, which is maybe or perhaps mostly an intranode exploration. It is a CPU utilization. It gives you some memory bandwidth and some of the floating point goodness that is monitored. Only these three aspects, right? For the MPI performance snapshot, MPS, you would look at basically imbalance and some high-level things like CPI rate and memory usage and flops as well. And the performance snapshot, I haven't used so far myself, but it gives you an idea on the I/O boundness and the storage and network saturation that you see with your application. It also, again, as all the three snapshots, it produces some CPU utilization numbers along the path, which is really just augmenting the information. And you can see in the first part, in this application performance snapshot, here is just mentioned that you can download it separately. You can see the URL on top of the slide. And the performance snapshot is basically something that gives you the utilization, intranode utilization. And you can see you get some percentages of utilization for the CPU for the CPU part, for the sequential code, for the floating point performance, and for the memory boundness of the application. I think these are the most important ingredients that you have anyways. And you can also get some further advice on how to go further with this. And the output looks like this blue thing that you can see on this slide. And I believe, yeah, it's just sourcing the tools in the usual way. I think it's module load, and maybe on your Cray system, in addition, you may look at opt-Intel. It's a path that you have on the file system, and it's the typical default path where Intel installs the tools, and you may find it underneath of the compilers and libraries version, which is the year mark and some sub-thing, and underneath of it, you can find this kind of APS.sh, which is essentially like a shell script. And the way to use that is on Linux. We obviously talk only about this aspect. Is you would write APS.sh, the application name, and then the application or workload arguments, and then that's it. I think then you get this kind of HTML output and some ranking. What I found so far for the intranode performance, just as a feedback probably that I have to give back to our teams that work on that, they essentially rated the floating point performance, obviously vector utilization and things like this. I found that they told my double precision algorithm as they called it single precision flops. So it was like a mistake in there somehow. So I did only double precision computations, but the whole thing showed me, oh, this is 600 gigaflops of SP, which wasn't the case, which was just double precision performance. Anyways, there might be some ACK in there, but could be a useful tool, I think. The MPI performance is probably, it's even more it's lightweight, and it's probably more useful to produce a similar output. You can see some or you can get some introduction on the load imbalance and some graphs and ranking for this aspect of the application. And I think this is very useful. You can see the same thing basically if you use VTune and things like this, and if you see that your MPI weight and those applications or hotspots are in the top rank, in the top view of your hotspots, then you know that not the weight is slow, obviously, but your application may have some imbalance because you essentially wait for some slower path, like a single MPI rank or a few of them. I think that's it from that perspective. You can have some stat levels that you add to it, and you can also redirect output just out of this HTML. You can get it separately on a standard output. You can get some statistics about the communication used, but this is not very new. This is something that was always present in Intel MPI. You can generate with an environment variable. You can generate some various summaries of communication patterns and MPI function groups and monitor those separately. But this is just leveraging this infrastructure, I think. Again, here is the summary for the MPS. You do the same. You would, for Intel MPI, you do MPI run -MPS, and then the usual rest of the command line that gives you the MPI run, but also adds this aspect. And you can also do, I think, this separately by prepending the MPS run.sh for the standalone version. You can see this. Maybe that's the way to go for if you want to try that with the Cray MPI. HTML report looks like this. You get some MPI performance snapshot, and basically, you can see calculation versus communication. The red part is the communication. And some statistics underneath of it, and then scoring for it. And as I said, if you find high-level outputs, charts, and graphics like cumbersome, you can go for the old school way, and you can just generate some console output as well. And you can customize it towards what you are interested on, essentially. You can go for what kind of communication group you are interested in. Anyhow, I think then there is one last piece left with this. You might look at the storage performance as well. And it gives you also the saturation of your network and things like this. And then gives you details on where the time is spent with the CPU, whether it's user code, system calls, and I/O wait, and for the CPU chart in the lower part of the slide deck. And for the memory, you can see what amount of the memory is used for caching, for buffers, and which amount is left over as a free memory. And then for the network, you can see the send-receive buckets separately for the network saturation. And disk and whatever file system is underlying, you can see also in terms of a graph over time. So you can see if the application is I/O bound in some of the phases, or whether it's a constant high I/O usage. So as I said, it's a very simplistic view. You can see the number of IOPS over the time. This is basically what you can see in the lower part, and you can also see the same thing for the network. One aspect that could be of interest is also the page faults. If your application is bottlenecked by some page faults, by some pages that are not in memory yet, or that could also have something to do with not really out of bound accesses, but prefetching over the end of a buffer or things like this. And with this, I think, I'm open to questions. If there is something you want to know about, there's one question here.
So I have a very naive question. Are there any assumptions in any of these tools, vTune, MPS, that the code has been compiled with the Intel compiler?
A good question. Let me answer that this is obviously a separate download, and for the MPS part, it just intercepts MPI calls. And as we heard, that MPI version 3 attempted to standardize the application binary interface. So it should work to actually change the MPI underneath of a already compiled and linked application, if you linked it dynamically, of course, if. And for the intranode, if it is sampling, if this intranode performance exploration, I will go to vTune separately, if this is based on sampling, it works on any CPU. It doesn't even require an Intel CPU, because sampling is just populating an interrupt that is called back in a regular fashion, like a clock tick. And if it depends, or if it is able to utilize a kernel driver for the performance monitoring unit, then it works separately, or differently. You perhaps know performance monitoring is more lightweight. It doesn't add almost no overhead to performance explorations, because you program a special chip part to call you back once you reach a certain level of events, right? That is the idea. And so there is no constantly sampling clock tick running all the time, adding the big overhead. Instead, the performance monitoring unit monitors itself once the watermark for the event is reached, and then it issues a callback into the application, which is vTune, for instance, or maybe that part or that tool, I don't know. In case of vTune, you would then do the more heavier part. You would sample the stack, collect the symbols that are known, and you do that every time you get called, but only during that time you have some little overhead to add to the vTune database and to collect this information. And later on, the post-processing of that kind of information is separate from the runtime of the application, which is obviously a necessity for fast performance in that kind of performance analysis. And with VTune, to answer that question, there is no dependence in particular on the Intel compiler. So VTune works well with GCC. What we always recommend, but this is a very simplistic recommendation, include debug symbols. Obviously something. What you can do as well is there is, say, convenience behavior, but I won't like to steal the thunder from Michael Clem's talk, but I maybe just add this. You can do remote sampling with SSH, which you could always do, but now it's more, you can do it with a GUI dialog. You can essentially name a remote machine, collect performance results there, and display it somewhere else. You can do the performance collection with command line interface only, tar the results, and then open it on your laptop. That same thing works for Mac, since I see that you run on a Mac. VTune doesn't have capability to do the profiling on the Mac itself, but the GUI is as capable as everywhere else. So if you did the profiling somewhere, you can just view it. And the interesting thing is the binaries, the symbol formats, whether it's 12, 11, whatever it is, it works on any of these, independent of the platform. So what you can do is you can transfer the binary into any directory you want, and when you double click for the assembly view, it sometimes wants to disassemble and go to the module. And if the binary is then also put into the result directory, you can anytime look at the status that you had and look at the generated code. And there are really nice things that has nothing to do with Intel compiler. I think even very convenience options like show a function as if it is not inlined, for instance. That was one thing that we had in the past. I believe that also works on GCC meanwhile. So if you had inlined functions, it is convenient to show it as if it is not inlined, because otherwise you have just a huge code blob, right? Okay.
So thanks for that very complete answer. So if I can just summarize, in principle, there's no issue with other compilers, Cray or GCC?
No issue.
Okay. Thanks.
There is a little issue with the advisor tool that we heard about yesterday, because it depends on binary instrumentation, which is also portable across compilers, right? You can instrument for the load instruction and it doesn't matter which compiler generated that instruction. But smart enough, the tool leverages what we called optimization reports in the past. And the way it works is it essentially attaches a binary variant of that optimization report to the binary, essentially. And if this binary report isn't there, obviously the tool is not as useful. But the team working on Advisor, they are definitely interested to make this not only useful for Intel compiler. Yeah. But there is a bigger gap because of the technology behind it.
Thank you.
Okay. So welcome to a very small piece. It's supposedly holding for 15 minutes. It is something that I just put into it out of interest. It's not really a key tool that you have to use. In fact, it's more like, not really a marketing, but it produces a high-level result. It gives you a performance snapshot of your application. And we will look at how that actually looks like. It generates kind of HTML output, something that you can just snapshot as a picture and somewhere include into a slide. The idea here is you can just explore three aspects of your program, which is the intranode performance, and it is the MPI communication performance, and it is something else. It is the storage performance that you can look at if you want. And it leverages, if you have these Intel tools, it leverages the existing infrastructure like the drivers, the kernel drivers that are kind of an application snapshot. Okay, let's look at this. Objectives here are just to learn about these performance snapshots and then to get hands-on and eventually try it for reporting the success or the progress of your project to some extent. If you report to someone what you did and what the progress and result was, you might have some fun with this. Essentially, as I said, you run a test case, and the intranode performance is used to extract performance results from the performance monitoring unit, which is part of the CPU. But the interesting part is also that you can download this separately, free of charge, and it is like a shell script that you just launch and prepend to the execution of your application. And then you can explore these three aspects and just get kind of three different charts with, say, high-level detail, and not really deep details or analysis, but some, really the name says it. It's just using either sampling to sample performance numbers from the CPU, or it eventually uses the performance monitoring unit. I don't know. I have to ask the developers what kind of mechanism they use. What I heard is for the intranode performance, it seemed to be sampling. The last people at Bologna, they tried this and they found it used sampling for gathering the performance results, which obviously has some impact on runtime of the application itself. But there is also a communication and